Hello and welcome to Nostalgic Ramble with me. I am looking at IEB May 2024 paper 2. In this video, we're looking at question 1A. This is an inaugural statistics question on this channel, I believe, so yeah, I'm going to try my best to keep a positive attitude. Right. The scatter graph shows the age of 8 individuals and their maximum heart rate in beats per minute after a particular exercise program. Okay, so for example, we have this point here, which is a 22-year-old whose heart rate went all the way up to 180 beats per minute. This is a 39-year-old whose maximum heart rate just went to 90, and we have here a 45-year-old whose heart rate went all the way up to 200. So that's what this data means. Just looking at it, it doesn't look like there's a correlation between the two variables, between age and the maximum heart rate. Because you typically when there's a correlation, you'll see like the points are kind of bunched together, or they kind of form some kind of a trend, maybe like a linear trend or a parabola or something. This is just looking all over the place. So I suspect that when we crunch the numbers, we're going to find that there is close to zero correlation between these two variables, at least for this data set. And speaking of which, that is the very first task. We need to use our calculators to determine the equation for the line of best fit in the form y is equal to a plus bx. Give your answer correct to 3 decimal places. So essentially we need to work out the value of a and the value of b so that we can see what the line of best fit looks like. Maybe it's going to be something like that. Maybe, I don't know. Anyway, let's see. My calculator does look a bit different to the standard school calculator, I guess. So yeah, I didn't really want to go into the hassle of figuring out how to fool myself using a physical calculator, and I really want to do minimal editing on this channel, so right. But if it really is something that you'd like me to demonstrate, then I will make another video demonstrating how to get the values for A and B on the kind of calculator that you would be using at school. Right, so first up I need to get into stats mode. Then I need to choose, in my case I choose a plus bx. Then it's time to enter the data. So we'll start with this point, which is 22 and 180. Well, I'm just going to do the ages first, actually. It's just easier that way. This one is age 24. This one is age 27, 30, 35, 39, 43, and 45. And then I'll do the y values, so the maximum heart rate. So this one was 180, this one was 150, this one was 120, the next one was also 180, the next one was 110, the next one was 90, the following one was 110 as well, and then the last one was 200. Right, so my data is all stored and all is well. Then I'll shift 1 to get to the stat option, and then I have this nice option to say calculate all things regression related, and I get my values there. My A is 171,98, and they say to 3 decimal places 93. My B is negative 0,890, And the correlation is negative 0.19, about negative 0.2. So very close to 0, which is as we suspected. There's almost no correlation between these two variables. So let's jot this down then. Y is equal to 171,983 minus 0.890x, right? And we can test for a couple of values, just kind of sanity check. And mind you, my prediction of how the line was going to look was wrong. Our gradient is negative. Yeah, our gradient is negative 0.89, so something close to negative 1. Anyway, and it's crossing the y-axis somewhere over there, so that's what our line would look like, maybe. Just as a very rough guesstimate. Okay, right. And let's just see some calculations. I wonder if I can do normal calculations here, can I? So if I say 171.983 minus 0.89 times, and we just pick, let's pick this guy, so age 35, we're expecting our answer to be somewhere close to 110. But we can see that our line of base fit is actually quite far from that value, so it's actually maybe going to be closer to 140. But let's see, so 0.89 times 35, yeah, you see we get something close to 140. So really not a great line. Well, I mean, it's a good line of best fit. It's just trying to organize data that is not very organized. And so, yeah. Anyway, that is my answer for that. Then next up, we are asked to use the equation that we got in the first part of the question to predict the maximum heart rate of a typical 50-year-old individual. Now, very important when you get questions like this to ask yourself, are we interpolating or are we extrapolating? And, you know, in a data set like this where there's such a weak correlation between age and heart rate, even if you're interpolating, you still wouldn't get a value that says much because yeah, the relationship between the two variables just isn't strong. But worse when you extrapolate, worse, because the danger of extrapolating is we don't know what happens beyond the range of the data that we've got. So beyond, you know, when people are older than 45 or when people are younger than 22, might find that people younger than 22 are generally you know, their heart rates are a lot more stable, maybe. So, you know, even after vigorous exercise, their heart rates might not actually shoot up all that high. Or people older than 45, I don't know medical stuff. But, you know, there might be something there as well that would influence, or that could influence this value. Maybe there's a higher prevalence of a certain kind of cardiological disease in people older than 45 that would influence this number. And so even, you know, so if we currently have this negative trend from our previous graph, and we might find that with this particular cardiological issue that occurs a lot for people over 45, that heart rate actually tends to go up again. So yeah, we don't know, we don't really have grounds to speak about data that lies outside this range. There's also the fact that, and I think this is also stepping on the toes of the next question, but this is a data set of 8 people. 8, really? You are going to conduct a study with just 8 people and expect to have something authoritative to say? So that's not good either. Anyway, but for now, we're just going to naively use our equation to do the number crunching. So in our case, the X that we've been given, the age that we're needing to work with is 50. And so Y would be 171.983 minus 0.89 times 50. And maybe we can just round that off to the nearest whole number, like we're working with whole numbers. So that would be 127 beats per minute, right? Yeah. And so the last question asks us, give 2 reasons why the prediction in number 2 may not be reliable. So yeah, it's pretty much, we would talk about the dangers of extrapolating and, basically just describing that if our data set is based on people between the ages of 22 and 45, we don't really have then the authority to speak on data points that lie outside of that range, just because there might be a whole other set of variables influencing those data points that might not be present in the current data set. So that would be the one point to talk about. And then the other point to talk about would be the size of the data set. It's just way too tiny. And on top of that, it doesn't help that the correlation is just so weak between the two variables. So yeah, even this equation that we found that attempts to describe a relationship between the two variables, there isn't really a cause and effect relationship between the two variables. So yeah, that, I guess that would be the other point, is just R is what? Where are my numbers? So R is negative 0,191. R is negative 0,191, which is very close to 0. So there just isn't really much of a relationship between the two variables. So those would be the answers that I would venture. Let's see what the memo has to say. I am so ready to be humbled because, wow, I did a 1-hour crash course and I'm hoping that was enough for me to make sense. So let's see. Our equation is indeed the same. Yes, yes, fantastic. Then we plonk the 50 into the x and we get, they rounded it off to 1 decimal place, so they got 127,5. I don't know how intense that would be, like how intensely they'd mark that. Is there an instruction about answers having to be to 1 decimal place? Anyway, I guess, yeah, just follow the instruction. The superior instruction is the one on the front cover of your exam. They'll tell you what the standard rounding rule for the exam is. And then, as we saw in the first part of the question, some questions will specifically ask you to round to 3 decimal places, or in the case of like finance, it's kind of implied that you round to 2 decimal places because you're dealing with currency. Anyway, so yeah, long story for why I should have written 127,5 instead of 127. And then the next question, they talk about, extrapolation, the dangers of extrapolation. 50 is outside of the given range. And then they also talk about the weak correlation of negative 0,2. I don't know why they're not mentioning the small data set, because that's also, I guess maybe, would you have more grounds to extrapolate if your data set was larger? So if we had monitored 1,000 people, would it make it any more right, any more okay to extrapolate? Probably not. Yeah, I guess you'll talk about the size of the data set more for interpolation. Yeah, I think in the case where if they had asked you to work out, say, for a 32-year-old, what the maximum heart rate would be, and they asked you to talk about why that might not be a reliable number, this would still be relevant. And then the size of the data set would also be another relevant factor, I think, at least in that case. So yeah, we can scratch out size of the data set over here, because even if your data set was very big, um, it's still dangerous to extrapolate, for the same reasons that I spoke about. Yeah, so oops, my bad. That's that on that question. And let us conclude there. See you another time.